Hello everyone. This is a sort of a recording for Mathematics 4, that is BES MAT22. It was necessitated by mainly the performances that I observed in the April examination, and therefore in this recording and the next one, which we'll call Algebra1, I'll be covering mainly topics in algebra where students experience problems the most. In this case, I would like to welcome you, and I hope you pay attention. But again, as I said, it's really just meant for preparations for your August and November examination. And we'll just take a brief look at some of the topics that students experience problems with in algebra. And therefore, I would like to emphasize, as I always do, that this presentation should not be taken as a substitute for your study guide. I'm not saying that this is all you need to know for your examination. You need to know a lot more. I'm only covering topics that I thought students needed a bit of help. So you need to cover the whole of the study guide in preparation for your examination. So please supplement the study guide with either the literature that's mentioned in there, or any other textbook that carry topics that we cover in the study guide. It should be able to help you. The first topic I want us to look at is on simplifying algebraic expressions. It's a bit tricky in most cases, but it's a very easy thing to do. And what we have is, if you have an expression that involves exponents, then we might need to use laws of exponents. Otherwise, if you have fractions, for example, then you need to know how to add or subtract fractions. You need to know how to multiply fractions, and you need to know how to divide fractions. Otherwise, in the end, you also need to know how to collect the like terms. Like terms are terms that have the same variable and so on, which means the only difference might be the coefficient in front. But and therefore that's what we have. So by simplifying an algebraic expression, we mean writing it in the most compact and efficient manner without changing the value of the expression. Which means if the value of the expression that you end up with is not the same as the one that you started with, the one that was given, then you have changed the expression. You've not simplified it, but you've rather changed it. So, and as I said, this is done by mainly collecting the like terms, which means that we add together anything that can be added together. Anything which only varies at the coefficient in front, those can be added together. Otherwise, if you have a fraction, then we also cancel out terms that can be cancelled out. If you have 2 on top and you have 2 at the bottom, then obviously 2 divided by 2 gives you 1, isn't it? And therefore, that can be cancelled out, and so on. Now, I mentioned earlier that in cases when you have exponents, then we use the laws of exponents. I've given these laws of exponents to you, I think, in my earlier recordings, but I feel it's necessary that I provide them again, and maybe I can just go through them a little bit one by one, just so that we understand what they are saying. A, for example, is saying that if you have 2 exponents with the same base, and you multiply those 2 exponents, then you keep the base and then you just add the exponents, you just add the power. So which means x to the power m multiplied by x to the power n gives you x to the power m plus n. And then subtraction is almost the same, because if you have x to the power of n minus 1, or x to the power of negative n, sorry, then that's the same as 1 divided by x to the power of n. And therefore, x to the power of m divided by x to the power of n is the same as x to the power of m multiplied by x to the power of negative n. And then you just use what we learned in A, that now you are multiplying, and therefore you are adding the power, so you have m plus negative n, that gives you x to the power of m minus n. In C, if you have x to the power m and raise that to the power of another n, then that's the same as x to the product of the exponents. While if you have a product of full numbers and you raise them to the power of an exponent, then that is the same as the product of individual exponents. So, and of course the other one can be treated in the same manner that follows, that x to the power of m multiplied by y all to the power of n is the same as you basically distributing the power n inside the brackets. The E is similar to D, only in this case you have division, that a power of a quotient, a power of x divided by y, is the same as the quotient of the powers. Of course, we can only do that provided that y is not equal to 0, because when y is 0, then you know that we don't divide with 0, and therefore it will not make sense. In your F, same thing, only in this case you have a negative in front of your m, and therefore when you have the negative, then you take the reciprocal, isn't it? So the next one follows, and so is G, and so is your H. So these are the laws of exponents that we need to know and we need to use when we are simplifying algebraic expressions that involve exponents. And therefore, in that case, I want us to consider the following example. The first, and most of these examples are either taken from your assignments, your previous assignments, or they are taken from your April exam. So it's real practical examples that you can get in an exam. So the first one, so this is simplifying expressions. And the first one is that you are given an algebraic expression I'm sorry about that. You are given an algebraic expression that 2x squared y cubed all to the power of 3, and you are asked to simplify it. Now, if we look at this expression, it will probably be almost similar to what we have in D, in the laws of exponents that we have, which means first you start by distributing the exponent inside the bracket. So, and therefore in this case what we have is, maybe I should just keep the laws of exponents on so that we can refer to them easily. So in this case what we have is we distribute the power inside, and what we get is we get 2 to the power of 3 multiplied by x squared to the power of 3 multiplied by y cubed to the power of 3. So that is sorted. And then the next thing that we now need to do is we look at what we have in C. Okay? C says that if you have a power raised to another power, that's the same as your base raised to the product of the two powers, which means your outer power and your inner power can be multiplied to form the new power. And therefore, what we have is, the first one for the constant, of course, you have 2 to the power of 3, which is just 8, isn't it? And the second one is applying our third law of exponent, which is in C. We have x to the power of 2 multiplied by 3, which gives us 6, multiplied by y to the power of 3 multiplied by 3, and that gives us 9. Now, that is as simple as our expression can be, and we are done with the first one. So we have simplified this expression into a much more simpler and compact one without changing the value of the expression. So this is equal to that. It's just that this one is in a simpler form, but they are basically the same. So that's how you use the laws of exponents. Let's look at another one. Okay, in B we have -3 multiplied by m to the power of 3 k squared, and these are multiplied by 2m squared to the power k. Okay, so we are given this expression and we are asked to simplify it. Again, we want to write it in a simpler, compact, efficient way, but still we need to keep the value of the expression the same. And in this case, what we have is with the product of some powers. We have a product of powers, and therefore, if we look at A, then what we have in A is that you have a product of powers, and sometimes some of them with the same base, and therefore, if the base is the same, then all we need to do is add the powers. And therefore, we get the following. The first thing that we need to do is sort the coefficients, the constants, -3 and 2. That we have -3 multiplied by 2, that gives us what? -3 multiplied by 2, that gives us -6. So we have -6. And then the next thing that we do is we sort out the m. So this is the same as m multiplied, so m cubed multiplied by m squared. We have the same base, which is m, and therefore we just need to add the power. So we have m to the power of 3 plus 2. And then we lastly look at k. Again, we have the same base, k squared, k to the power of 2 multiplied by k to the power of 1. And then again, we can write that as k to the power of 2 plus 1. And then simplifying that, we get -6. And then m to the power of 3 plus 2, we get m to the power of 5. And then k to the power of 2 plus 1, which is k to the power of 3. And again, you are done. Your expression is now in a much more simpler form than it was in the given form. So that, again, we are just using the laws of exponents to simplify our expressions. Good. Now, and the last one that we'll look at involves fractional expression, which means algebraic expression in fraction form. And what we have is we have m squared plus 2m divided by m minus 4, and then we divide this with m squared minus 4 over 2m minus 8. So that's what we have. Now, the first thing that we note is that dividing by a fraction or dividing anything by a number is the same as multiplying with the reciprocal, which means 1 over what you have. And therefore, dividing our first expression by m squared minus 4 divided by 2m minus 8 is the same as multiplying with the reciprocal of this expression. In the reciprocal of this expression, you just flip it, and what you get is you get m squared plus 2m divided by m minus 4 multiplied by 2m minus 8 over m squared minus 4. That's the first thing that we have, and then we start to simplify. Multiplication of fractions, you just multiply the numerator and then you multiply the denominator. It's that straightforward. And then what we have is we note that we can factorize some of the terms, which means some of these terms have common factors. some of these terms, right, some of these terms have common factors. If you look at the first term, for example, on top, m squared plus 2m, both terms contains m as a factor, which means we can factor m out. And of course, we talk about factorization a little later, but these are easier cases of factorization, and therefore we should be able to handle them. So the top of the first fraction can be written as m multiplied by m plus 2, which means if you take one of the m out, then for the first term you're only left with 1m, and for the second term, if you take m out, you're only left with 2. And the top, sorry, not the top, but the bottom remains the same. And then we multiply this with the top or the second fraction, and we see that the second fraction also has a common factor, which means the first term has 2 as a factor, and 8 is also a multiple of 2. 8 is 2 times 4, and therefore we can also take one of the 2's out. And what we get is we have 2, then we have m minus, if you take 2 into 8, then you are only left with 4. As I said, 8 is 2 multiplied by 4, and therefore you take 2 out, you are left with 4. And the denominator can also be factorized. This is what we call a difference of squares, which means, I'll quickly put it here, that if you have a squared minus b squared, then this is the same as a minus b multiplied by a plus b. This is called the difference of squares, and that's what we need to use for the denominator of the second fraction. So this we can write as, so in this case our a is m and our b is 2, because 4 is 2 squared, and therefore we have m minus 2 and we have m plus 2. Now we can cancel some terms out. You have a term on top and a term at the bottom, which if you divide them, they'll give you 1. For example, if you divide m plus 2 by m plus 2, which we have down here, then you get 1. So the m plus 2 and the m plus 2 here cancel out. Second, you consider your m minus 4. You have m minus 4 on top, you have n minus 4 in the denominator. Those can also cancel out. And therefore, in the end, what you have on top, you just have m multiplied by 2, which gives you 2m. And then in the denominator, you are only left with m minus 2. And that is your term, that's your expression, your algebraic expression in its simplest form. So we have managed to write this algebraic expression in that simple term, in that simple form, where the two are still the same. They still have the same value. And therefore, that is what we have as our algebraic expression in its simplest form. Right, and then we move on to factorization. Factorization can be described as the process of finding the factors of the given expression. For example, if I give you 4, then 4 can be written, if you have a number 4, then 4 can be written as 2 times 2, or it can be written as 2 squared. So 4 can be factorized or can be factored into 2 squared. If you have a number, say 6, 6 can be factored, which means you write 6 as a product of its factors, can be written as 2 multiplied by 3. So for numbers, we normally write it as a product of its prime factors, which means numbers that can no longer be factored into except by 1. So in this case, we have 2 and 3, and the same can be said about all the other numbers. However, in our case, and then this is the simplest cases of factorization, you're factorizing natural numbers or integers, whichever case may be. But in this case, what we are interested in is we want to factorize algebraic expression. So what we do is you find what to multiply together to get the given expression. So if you are given the expression, then you want the bits that you need to multiply together to give you the given expression. So it's like splitting an expression into a product of simpler expression. Remember, as I said, in this case, we wrote 6 as a product of its prime factors. Those are the simpler expressions. So in this case, we look at the following examples and see if we can factorize them. And again, these examples, some were taken from your assignment, some were taken from your April examination. Therefore, we have the following. Factorize the following. In the first case, we have 18 x squared minus 50. We want to write this as a product of the bits that we multiply to get back to this original one. And in most cases, if you have, like in this case, a difference or a sum, then the first thing that you need to determine is whether you have any common factors for the two terms. And we realize that 18 here is divisible by 2, and 50 is also divisible by 2, which means 2 is a common factor for the two terms, and therefore we can take it out. So we can write this as 2, and then inside we have 9x squared minus 25. And then the second question that we need to ask ourselves is what we have between the brackets the simplest we can get? 9x squared minus 25. But we realize that, remember in the previous slide we talked about the difference of squares. You have a square minus another square. That's a difference of squares. And as we said, maybe I should just write it here, difference of squares. Because, and the reason I'm saying this is because for most students in the previous assignment, they stopped here. They could not realize that this term between the brackets can be factorized further. Now, difference of squares, as I said, you have a squared minus b squared can be factorized as a minus b multiplied by a plus b. That's how you factorize a difference of squares. So you just need to recognize that you are looking at a difference of squares. So in our case, for 9x squared minus 25, I'll just look at 9x minus 25 for now, and then we can bring it all together in the end. What you realize is that 9 is a square because it's 3 squared. 9 is a square of 3. X squared is a square of x, which means we can write this as 3 multiplied by x all squared. And then for the second term, 25, we also need to recognize that that's also a square. 25 is 5 squared, and therefore we can write it as 5 squared. Now we have our expression in the form of a squared minus b squared, which we have here. And therefore, we can now use this law, the factorization law for the difference of squares, to factorize what we have here. Remember what we said? This can be written as a squared minus b squared can be written as a minus b multiplied by a plus b. And therefore, we have our a in this case is 3x. So we have 3x minus 5, which is our b, multiplied by 3x plus 5. So that's your 9x squared minus 25 in a factorized form. So if we then put all this together, we go back to our initial term there, and we just substitute wherever we have 9x squared minus 25, we substitute with this. And then what we get is we get 18x squared minus 50 can therefore be factorized as 2 multiplied by 3x minus 5 multiplied by 3x plus 5. So now that is complete. We have managed to factorize 18x squared minus 50. We've managed to write it as a product of simpler bits, simpler terms, and that is now complete, because this, although you've written it as a product of terms that are simpler than the initial one, they are not the simplest that you can get. We still needed to factorize the 9x squared minus 25. So whenever you are factorizing, always examine the terms that are remaining if there's a possibility of you factorizing them any further. So in this case, this is what we have. Remember, we used the difference of squares. Difference of squares, a squared minus b squared, that's a square minus another square, can be factorized as a minus b multiplied by a plus b. Good. And then we look at the second example. In the second example, what we have is we have 2x squared plus 5x minus 3. These types of algebraic expression are referred to as the quadratic expressions. It's a type of a polynomial, but quadratic expressions are expressions of the form ax squared plus bx plus c. Any term that is written in this form, any expression, algebraic expression that is written in that form is called a quadratic expression. Now, and of course it's quadratic because the highest power in this, highest power of the unknown, the highest power of your variable x is 2. Good. Now, how do we factorize algebraic expression? There may be other methods, but the method that I use is we use the product sum method. Now, the product in this case is your a multiplied by c. That's your product. And then your sum is b. Now, to begin factorizing this, what you first need to determine is, and of course, I'm not saying we can do this for all quadratic expression, but for some quadratic expression can be factorized, others cannot be factorized, they are already in their simplest form. It's the same as 6 can be factorized into 2 and 3, but 3 cannot be factored any further into product of its prime factors, because 3 is a prime already. It's as simple as it can get. So in this case, you identify your product, and then you identify your sum. And now you determine what two numbers, you find two numbers such that if you multiply those two numbers, you are getting your product. And if you add those two numbers, you are getting your sum. I'll repeat that again. You identify your product. Your product is the coefficient of x squared multiplied by the free coefficient, the constant coefficient, some people might call it. That's your product, which means you have AC. And then your sum is the coefficient of x. Now you determine two numbers such that if you multiply them together, they'll give you your product. And if you add them, they will give you your sum. Okay? And of course, we take it from there. Now, in our case, our product, that gives us our product, A multiplied by C. So our product is 2 multiplied by -3, which is -6. Remember, your coefficients must carry their signs. Like in this case, 2 is positive, and therefore you just have 2, but -3 should come with its sign. It's not 2 multiplied by 3, but 2 multiplied by -3. That gives you -6 as your product. And then you have your sum, which is the coefficient of x, and that is 5. And now you need to you need to find two numbers such that if you multiply them, they will give you 6, -6. The product of those numbers must give you -6, and if you add them, then you get 5. What are those two numbers? We can start with first looking at all the possible combinations of numbers that can be multiplied to give us -6, and then we see which ones, if we add them, they will give us -6. So we can have -6, can be written as -6 multiplied by 1. It can be written as 1 multiplied by 6. It can be written as -2 multiplied by 3, and can be written as -3 multiplied by 2. And I think that's what we have, isn't it? And now we need to examine these two combinations and see which of these two numbers, or this combination of two numbers, can be added to get 5. If you look at the first one, you have -6 plus 1, you are getting -5. So we don't have 5. You look at the second one, you have -1 plus 6. That gives us 5, isn't it? This one gives us the correct combination. If you look at the other two, their sum will either be 1 or -1, and therefore those two are also out. And therefore the second combination gives us what we want, that if we multiply them, we get -6, and if we add them, then we get 5, which we want. And therefore we write, having found our desired combination, we then rewrite our quadratic expression in the following form. So 2x squared plus 5x minus 3 can therefore be written as follows. We have 2x squared, and then since we said that 5 can be written as a sum of these two numbers, then we have the following, that we have minus x plus 6x. This is the same as 5x, which means the numbers that we got here, we use it to rewrite 5x as a sum of the two numbers that we obtained. And then, of course, our last term, -3, is still here. Now we start to group these two, not two, now there are four. We start to group these four terms. We consider the first two, and then we consider the last two. And for the first two, by grouping, we are grouping so that we take the common factors of these two pairs of terms. Which means for the first two terms, they have x as a common factor. The first one we have 2x squared, we have x as a factor there, and the second one we have negative x, which we also have x as a factor there. And therefore, we write this as x, and then inside we are left with 2x. If you take one x out, then you're only left with 2x minus 1. Because you've taken x out, you are only left with 1. And then for the second pair of terms, your plus 6 minus 3, we note that 3 is also a common factor, because 6 is 2 times 3, and 3, not 3 but negative 3, negative 3 is 3 times negative 1. And therefore, we can also take out 3 in this case, and we are left with 2x minus 1. Now, now we have two terms. We have this term and we have that term, and both terms contain 2x minus 1. So we can then factor 2x minus 1 out, and what we are left here with is just x, and what we are left with in the second term is just 3. And therefore, we managed to factorize our quadratic expression into a product of two simpler terms, which means your 2x squared plus 5x minus 3 can be written as 2x minus 1 multiplied by x plus 3. So that's how you factorize quadratic expressions. Just a recap, you determine your product. Product is a multiplied by c, the coefficient of x squared, multiplied by the free coefficient. That gives you your product. Your sum is the coefficient of x, and then which means that's your b. And then you determine two numbers such that if you multiply them, they'll give you your product, and if you add them, they'll give you your sum. Once you determine those two numbers, then you rewrite the middle term as a sum of the two numbers that you found. And then you group, you factorize, and then you get your answer. Okay? So I hope we got that, and we should be able to factorize quadratic expression in future. I just want to, maybe talking about grouping, I just want to take a look at one more example that involves grouping. We have 3y plus 4pq minus 3p minus 4yq. Okay, we have four terms. All of them are slightly different from the others, but the point is that we still want to group. By grouping, you group terms that have common factors together. Okay, and therefore, this term can be written, for example, the first term contains y, and the last term also contains y. And therefore, we can write this as 3y minus 4yq, and then we have plus 4pq minus 3p. Okay, so the first two terms contain y, the last two terms also contain p, so they also have a common factor, and therefore we just again group like we did in the previous example, and we factor the common terms out. For the first one, we can write this as y, and then we have 3 minus 4q. And in the last one, we have plus p, 4q minus 3. Okay. Now remember, at this point in the previous example, we had the terms in the brackets, they were the same. Okay, and therefore, which means we had a common factor again, which we could take out. But in this case, they seem the same, but they are not exactly the same. The difference is that 3 minus 4q is the same as 4q minus 3 multiplied by negative 1. And therefore, so if we have, I'll just squeeze it on the side here. If we have 4q minus 3, this can be written as minus 3 minus 4q. Remember, if you multiply throughout with this negative 1, you're getting negative 3 plus 4q, which is exactly the same as that if you just interchange the 2. And therefore, we can then write this as 3 minus 4q. And then we have minus p, 3 minus 4q. Okay, so it's the same as having 2 and negative 2. Okay, so if you take 2 out, you are left with a negative sign, isn't it? So that negative sign, you can take it out and you are left with 2, and now you have 2 and 2 with a negative sign outside the brackets. So if you have 2 here, if you have negative 2, you can write it as negative and 2 inside. So it's really just the same. Now, your 3 minus 4q is now common to the two terms, and therefore we can factor it out, and we can write it as 3 minus 4q. And then for the first term, we are left with y, and for the second term, we are left with p. And now we have managed to factorize our expression, algebraic expression, into products of simpler expressions. But remember, these two are still the same. So in both these two cases, factorization is also, remember we are saying you are writing it in simpler terms, is also a way of simplifying. Okay, so this term is much more simpler than the expression that we are given in the beginning. Good. So this should sort you out, hopefully, when it comes to simplifying algebraic expressions and factorizing algebraic expression. Okay, and this is just what I said in the beginning, that it's not an exhaustive presentation. It's really just meant to touch some of the topics that I picked up students experience problems with, and so on. Again, I would like to emphasize that please, you need to study the whole of your study guide in preparation for your examination. Do as many exercises as possible. Remember what we say, we don't study mathematics the same way we study history, for example. I don't mean no disrespect to history. But when it comes to mathematics, we do it. We don't simply just read through the study guide. You study with a pen and a paper, doing your exercises, and practice makes perfect, as they always say. Okay, and I wish you all the luck with your presentation, but I'll see you again in our next presentation for Algebra 2.